We got one more. Back in.
The first requirement for this project was to build a rocket that would go 70 feet with a B-64 engine. We initially thought that 3D printing a paraboloid would be the best way to make our rocket aerodynamic, but it ended up being too heavy. The second requirement for this project was that we had to protect an egg inside of the rocket. Initially, we decided to protect the egg inside of a larger plastic egg that was filled with stuffing, but after many trials, we soon found that bubble wrap would work better for us than any other soft material. The last challenge we had to face was getting our rocket to land within a 100-foot radius of the launch site. Using a parachute could have taken the rocket further than 100 feet away, but when we did not use one, it crashed. The first design was very aerodynamic and included a parachute. The pressure from the engine would be ventilated around the egg so that the egg would not be cracked, and the egg screwed into the rocket inside of a chamber. Our second design had the egg in the top of the rocket that would be shot off after the pressure from the engine. At this point, we also wanted to see what difference fins at a 20-degree angle would make to the launch of the rocket versus fins that were pointing straight up. For the final design, we made an adaptation of the second design, made completely out of paper with a pointed cone at the top of the rocket. To test the effect of spinning fins and a paraboloid on top of the rocket, we made a second rocket to launch that had these two variables. We tested our rockets many times before they were due. One rocket was even launched the night before we would launch them at school. At the day of the launch, both rockets reached the required height and landed within 100 feet of the launch site, but only the rocket with the straight fins was able to protect the egg inside. Neither rocket's parachute deployed correctly, and the second rocket's egg would probably have survived if the parachute had worked. To calculate the height that the rocket reached, two people stood 200 feet apart with the launch site directly in between them. Angle finders made out of protractors, straws, and string were used to find the angle of elevation at which the rocket was in relation to us. Once the measurement of the angles were found, we used this equation and the angle measurements to find out how high the rocket went. After solving the equation, we found that our rocket had reached 98.48 feet. Although our rockets succeeded for the most part, it would still be nice if we had had a working parachute that was more reliable than the two that we used.